In this video, we are going to talk about how to locate the center of mass of a rod. So we have a rod here of mass m and length l, and let's say the mass is uniformly distributed. That means the mass per unit length is constant. So let's say lambda is equal to mass per unit length, which is constant. So here lambda is constant, right? Now we have to find out the center of mass of this rod. So how will you find the center of mass of the rod? So basically it is the weighted average of masses. That means suppose I take this as my origin over here and I take a small mass here, let's say dm, okay, and let's say this has the length dx, right? Basically you know that XCOM, that is the center of mass coordinate in x coordinate of the center of mass, basically is m1 x1 plus m2 x2 plus m3 x3 and so on, divided by the total mass m1 plus m2 plus m3 and so on, right? Now this is for the discrete system. Now this rod is a continuous system. That means we have to do integration. Now the integration will be like this. Suppose we have at a distance x from the origin a mass of dm and the length is dx, right? So here the contribution of this term will be x times dm, right? And we have to add all these terms, so we have to integrate, right? So this will be XCOM, that is the x coordinate of the center of mass. Now we have to divide by total mass. So total mass will be integral dm. So here what we will get as x dm. Now see here we have lambda as mass per unit length, right? So lambda is mass per unit length, that is lambda can be written as this mass dm divided by dx. Of course this will be equal to m by l only. Why? Because the mass is a uniformly distributed mass. So here we can write instead of dm as lambda dx. So let me write over here dm is equal to lambda times dx. So let me put this over here. So we will get x integral lambda dx divided by integral of dm. So since the mass of the rod is capital M, we have in the denominator capital M. So let me write it over here, capital M in the denominator. Lambda is a constant, so lambda I will take it out and this is x dx. So what are the limits for this integration? So it will be from 0 to L, because the L is the total length of the rod. So this will be lambda by M into integral x dx will be x square by 2, and the limits are from L 0 to L basically. So this will be lambda by L, lambda by m into L square by 2 minus 0. So what this will become? This will become lambda upon m into L square by 2. Now what is lambda? Lambda is equal to m by L, that is mass per unit length. So m by L into m into 2 into L square. So m and m gets cancelled, L and L gets cancelled. We have L by 2 as the center of mass. So here at the length of L by 2 there will be the center of mass, that will be the middle part of the rod, right? So this is the middle part of the rod. Here will be the center of mass. Okay, we are assuming the mass there is no lateral dimensions that much big. Okay, so here we have this as a center of mass, right? Even if there were lateral dimensions, the center of mass would have been at the center itself. Okay, but we have taken it mostly as a one-dimensional system, right? Okay, so now let's look at the non-uniform distribution of mass. Suppose lambda is not constant, like this. Suppose we have a rod here, and let's say the rod's length is L basically, and the mass per unit length is not constant. Maybe the mass is more concentrated at this end. Okay, at this end the mass is more concentrated. As you go near to this end, the left end, the mass will be lesser concentrated. So let's say this is origin. So let's say lambda is equal to kx. That means as you go, the more the x is, more will be the mass per unit length. That is, mass is concentrated more and more as you go away from the origin, right? Now how will you find out the center of mass? So basically again the same thing. Let's take a small element over here. Let's say this is having mass dm, and the length of this will be dx, right? And let's say this is at a distance x from the origin, right? Okay. So now how will you find out the XCOM, that is the x coordinate of the center of mass? It will be integral of x dm divided by integral of dm, which is basically the formula that we use to find out center of mass. So now this one will be, what is x, what is dm? Basically dm will be, now lambda is equal to mass per unit length, right? So it will be dm by dx. Lambda will be dm by dx, that means dm will be lambda times dx. So I will directly write like this, dm is lambda times dx divided by dm. Let's say the total mass is m, so I will write here it as m. Okay, so now this will be equal to, now we cannot take lambda outside because lambda is not a constant, right? Lambda is not constant, so we cannot take it outside. So we can write it instead as kx directly. So this k is a constant basically. So this is x square dx integral divided by m mass, right? So this is x square dx. Now this integral will be from origin to the length L. So if I integrate this, then we will get x cube by L with the limits L and 0. So this will be equal to k by m L cube by 3 minus 0. So this will k by m into L cube by 3. Now basically we don't know what is k. So how will you find out the value of k? The answer to that is very simple. We know that lambda into dx is equal to dm, right? The infinitesimal mass. We can see it from here that lambda is dm by dx. So dm is lambda times dx. So dm will be lambda dx. So now if we do integral over this, so dm will become m, but which is nothing but integral over lambda dx. Now we can take k outside because it is a constant. This is x dx. So the limits are from 0 to L. So k times x square by 2. This is from L to 0. So this will become k L square by 2. This is equal to m, right? So what is k? K is equal to 2m by L square. From here you can find out k value. So we can put that k value over here. So what you will get k value as, it will be 2m by L square. This is m, this is L cube by 3, right? So this will get cancelled with this one. This m and m gets cancelled. So we will get 2L by 3, right? This will be 2L by 3. Now where is the center of mass located? It is located at a distance 2L by 3. See, now it is not L by 2. See, it is not in the middle, right? It is little bit far away from the middle because 2L by 3 is greater than L by 2. So it is little bit towards far away from the center towards the right side. Okay, because why? Because it is because more amount of mass is concentrated on the farther end. That is the reason. Okay, so if you get any question like this, maybe the lambda is given as k by x or k x to the power n, where n is any integer, then you can do these questions very easily, right?